Hi, biochemistry students. Today, this problem that we're going to solve involves chemical equilibrium, and we're actually solving for what's called the KEQ, and that is the equilibrium constant. And what it does is it allows chemists to get a feel for concentrations. Are they more favoring the reactant side, or are they favoring the product side? Now, these are only for reactions that go both ways. They're called reversible reactions. And so, in some cases, when you have a solution and chemicals are reacting, they'll form products. And then the products will turn around and go the other way and form reactants. And so, this is a useful equation to help with that. So, anyway, what we have up here is the equation at the top in symbol form, where we have coefficient letter, or a letter representing the coefficient. In this case, we have N in front of an A, and so M in front of a B is also the coefficient in front of the two reactants. And so over on the product side, we have X as a coefficient, Y, and then our products are C and D. So in symbol form, that's what that would look like. And then so what we have to do to get the equilibrium constant is we have to basically find the product of the products divided by the reactants. So whatever products we have, we'll multiply them together. But there's a catch, and in that, whatever the coefficient is in front of, in this case, the products here, would become the exponent, a multiplier exponent. Okay, so let's work on just to kind of see how these are done, and we'll look at the answer and we'll see what we get here. Okay, so in this reaction, we have 4HCl. You're going to see an AQ, that's for aqueous. That means it's a water-based solution. And then oxygen gas, chlorine gas, and then notice there's a coefficient to the gas, and then pure water. Now, because in these problems, pure things like water or pure solids, they get thrown out. So they're not really a part of the concentration part. Okay, so what we'll do then is let's now take our product over here of chlorine gas. It is a numerator, and there's two of them. The coefficient 2 becomes the exponent 2. Okay, so we have to square the value for that. Now, what we're looking for is moles for each of those. And then as our reactants, hydrochloric acid, and there's 4 of those, so there's an exponent 4, and there's only one oxygen, so there's not an exponent on that. All right, plugging in the numbers. So it turns out chlorine, the value then for that in the problem is 0.75. So in the problems, you will see the molar values listed, and then it's just a matter of plugging it in. So the most important thing is just getting your balanced equation and make sure you have things set up right. Okay, so for hydrochloric acid, we had a molarity of 2, but we have an exponent of 4. And then for the oxygen, we had 0.5. Okay, when we do all the math on that, crunch out the numbers, it turns out to be 0.07 molarity. Now, that tells us a little bit then. Actually, there is no unit for that. So it's just a number. The equilibrium is just a number. Now, what does it tell us? Anything less than 1 favors the reactants. Anything greater than 1 favors the products. So in this case, we have a more concentrated solution in the reactant side and a less concentrated on the product side. Now, if it had turned out to be 1, if there was a 1-to-1 relationship, then what we would have had would be equal concentration on both sides. Okay, I hope that helps, and thank you for watching.